Hey there, welcome to CMTEQ channel. You did the right thing to click on this tutorial because at the end of this tutorial, you'll know why and how mechanical buttons, like this one here, were changed into touch buttons on many devices. Why replace a mechanical switch? Well, it's simple because mechanical switches were off as time goes. All the multiple on-off ticked off eventually will wear off at some point and will stop working. There are even switch manufacturers that specify that this particular switch can be actioned 10,000 times, after which they can't guarantee if it will continue to operate properly. As a result of wearing off, there will be an increase in contact resistance, contact gap, creating a situation of a high resistance which causes voltage drop, as a perfect switch must have a low contact resistance. The same thing will happen in a switch like this. This also does the same on and off. Tick-tock. We can replace it in here and see its operation exactly the same as the push button we were having just now. On, off, tick-tock, tick-tock. Thus will also wear off as time goes. Because if you go into the datasheet of this switch select here, the datasheet might have information that you can only do this 20,000 times, after which this will stop working. Which means to maintain a lifelong product, you have to replace this too often. Depending on how often the switch will be auctioned, it might just take 5 years and then you need to replace it. Now, because engineers don't sleep, and someone came up with a touch technologies, because replacing this with a touch switch, you can just imagine all those mechanical problems, high resistance, voltage drop will disappear. Because all you need to do is to touch. Then boom, something will be actioned. Notice how cell phone manufacturers have now all replaced the old style keypad with touchscreen keypad, like this one on your screen. Now comes the question, how do touch sensing button works? Well, basically at the moment, we have two types of technology being implemented to achieve touch sensing buttons. We have capacitive sensing and inductive sensing. Inductive sensing technology is new. I'm not going to dive into that now. In this tutorial, how a touch button is based on a capacitive sensing technology. What you see here on your screen is basically a visual illustration of how touch buttons work. There are two types of capacitive sensing technologies: mutual capacitance and self-capacitance. I'm not going to dive into much of that theory. That's not the purpose of this tutorial. Although mutual capacitance is less dependent on a common reference, signal ground of a varying reference cannot be ignored. So in a case of a touch button, practically this one here is your touch. Okay, so this is your hand. As you bring your hand and touch the button, there is a capacitance that is created between your finger and the electrode where you are touching. And that capacitance is in this range of picofarads. And also the area in which you are standing. So, imagine your proximity sensing module here. You've got power. And this power supply here is reference to ground as well. Okay? Or it could also be a battery operated device like a 9-volt battery or anything. But remember, there is also a capacitor between your feet and the ground in which you're standing, and that capacitance is in a range of 100 picofarad. Now as you touch here, there's something happening from this electrode and the module that need to read what is happening between your finger touching the electrode and the input value that is coming into the module here. Now, there is about 3 methods used to sense whether you are touching
or you are just approaching, or whatever action is happening. So there is a charge transfer method. That's the first one. The second one is a relaxation oscillator circuit in which variance in capacitance is translated into variance in frequency. And the third one is a fixed frequency AC signal where the variance in capacitance is transferred into voltage differences using a fixed non-capacitor and an unknown capacitor. An unknown capacitor will be the capacitor that is between your finger and the plate, and also your feet level and the ground. But this one here is the capacitor that you can fix, that is connected on one of the IOs on your module so that it can balance with the two capacitors here, and this will serve to improve the touch sensing. So this is just an overview. Again, there is a lot more that can be said about it. There's a lot of theory on this. You can go look it up. Okay, now let's move on and see a real practical use of a capacitive sensing button.
Now, to demonstrate how touch sensing button work, I have a board here which implement a capacitive sensing technology. Now, let's connect this board into this circuit and see how it's going to operate. So all I'm going to do now is I'm going to remove the mechanical switch. Okay. Now I need power. I need to give power to the switch. Okay. There's power to the switch. As you can see, my touch button is operating, but we need to switch on this bundle of LEDs with our touch button as compared to the mechanical switch. Now, to complete this demonstration, I'm just going to change this bundle of LED and replace it with another bundle of LEDs. This one's here. Okay, so what we're going to do is, now, this is a positive and that's a negative. Okay, according to my LEDs configurations. So this is now acting as a mechanical switch, the ones that we've demonstrated here. So we're going to put our negative, and the positive end of the LEDs must go to the positive end of our 9-volt battery. So I'm just going to squeeze this in there like that. Now the only thing that's left to connect here is the power. So we need to connect our battery completely to form the circuit so we can fit into our touch button setup there. Now as you can see, the touch button is illuminated. It's getting power. Now if I just bring my finger there and touch there, we should be able to get our light working. There we go. I can be touching for 20,000 times, a million times, so long as there's still battery and these LEDs are still operating within the lifespan, and so long as the capacitive sensing IC remain in operational mode, nothing is going to break. We're not going to have the mechanical wear or contact gap increasing the resistance and voltage drop, causing all sort of trouble, replacing mechanical switch. All that problem is gone. But what if I want to switch on a bigger load like this, a motor, or let's say a light bulb compared to these LEDs? Well, imagine if I want to switch on something like this light bulb here. What am I going to do? Because this 9-volt battery might not be able to drive a 100-watt or a 50-watt light bulb. Well, what can I do? We can use intelligent relays and other electronics circuitry to make sure the things work. We are now talking about smart lighting. Okay, now let's see how we can switch on this bulb still using our touch button. Okay, so what I'm going to do is very simple. I'm going to disconnect my battery. Okay. I take away the battery. I don't need the battery anymore. I take away these LED bundles. Now I need to switch on this bigger load. We're assuming this is 100 watt incandescent light. We want to switch it on with this touch button. What are we going to do? Well, some electronic circuitry with relays. I've got something here ready. So what I'm going to do is very simple. Okay, so here I've got my setup. I've got a circuit wired. I've got a bigger load. I've got a relay with some electronic circuitries wired up there. Now remember, this load could be anything. It could be a motor, anything we could drive. We can just change this relay to a bigger relay so it can drive bigger currents. And we're still going to be able to use our touch buttons to drive this bigger load. So I've got the power to the touch button, and I've got the same power is also going into the load there as soon as the touch button is action. Now let me touch my button to demonstrate how mechanical switches on, off, ticked off have been successfully replaced with touch buttons. There you go. All I need is to touch. I don't have to action a switch. All I need to touch. All I need is to touch, and then we have our light coming on. And I could be starting a motor with this. I could be driving any sort of load that you can imagine. Just because of a touch of a button, a signal is being sent, and then something is happening. So this is how mechanical buttons were replaced with touch buttons. So guys, if you have learned anything in this tutorial, please don't forget to give it a thumbs up and subscribe to CMTEQ channel. Don't stay a stranger. Come back next time for more tutorial like this. Cheers.